Well, hello, everybody. Welcome to Webinar Wednesday, hosted by the Concrete Preservation Alliance. As always, I'm your buddy Scott with Vector Corrosion Technologies, here to be the moderator for today's webinar. Well, we've reached the end of the road. The road went through a couple of twists and turns. We've learned about evaluation of structures, cathodic protection, and even some post-tensioning solutions. And as you'll learn very soon, the road concludes through a culvert. So we're going to get going right now. I just wanted to note one thing for you guys, that this is the last webinar that we're doing for the Bridge Preservation series. And we've had over 6,000 participants in the past, in these 12 webinars, which is amazing. And all of these participants have come from all over the world, most countries, in fact. So we're truly a global series here, and we thank you for joining us. As you know, the Concrete Preservation Alliance is a growing coalition of organizations committed to advancing best practices in the field of infrastructure repair and concrete renewal. And we draw on our members to host these webinars and their expertise to share with you, the audience. So we hope you appreciate the learning that goes on. Speaking of our members, we have a good list here, and they again span the globe. And they're committed to fixing, saving structures and concrete renewal. As you know, if you've been here before, all of our events and webinars are hosted on the WeSaveStructures.info website under the events tab there. So as this is the final webinar of the Bridge Preservation series, there are currently no more webinars posted yet, but we are working on a new series to start up again in September. So check back to the website for that. But just a little bit of housekeeping. If you're looking for recordings or slide decks, presentation slides from all the past presentations and webinars, they're all hosted here on the events tab as well. So you can find everything there. But on to the main show today. We have a long bio here for Mr. Garth Wallace, but I'm going to tell you all the things you need to know about Garth. He's up until last year, was the longest serving member of Vector Construction. He began his career in 1981 on the very first concrete rehabilitation project that Vector engaged in. He's held all different kinds of positions through the organization, and he's been instrumental in a few organizations, ICRI, ACI, and PTI to be specific, on advancing standards and educating. That's what the guy does. So there's probably not many questions that Garth doesn't know the answer to in concrete repair, and that's what we brought him here today out of retirement to join us for this presentation. Garth's going to speak to us about culvert repair using geopolymer mortars, which is an innovative technique that you may not be familiar with. So this is a little bit of a tangent from the bridge side, but it's very relevant to that. And if there's two things I know about Garth, there's a third, but two things I know: he loves concrete repair, he loves golf, and Garth, you should have put a photo here of your granddaughter as well. But can you tell us what's going on with these photos here? It looks like it's a fancy golf course on the right.
Well, good morning, everybody. As Scott said, my name's Garth Wallace. I was around Vector for almost 40 years, and I'm still here part-time doing specialty stuff with some of the particularly special technologies that I helped bring into Vector, and what I'm going to talk about today is one of them. These pictures, well, one of them here is a slightly younger me by about 15 or 20 years. This is on a project where we actually supplied the fiberglass rebar you can just see on the right of the picture there for a bridge on the Alaska Highway up in the Yukon territories. Went up there to help them with that, and also installed some fiber optic sensors for a structural health monitoring system. The bottom right, as Scott mentioned, I'm an avid golfer. If there's any other avid golfers out there, they'll recognize this as the tee shot on the 17th hole, the road hole at the old course at St. Andrews. I was fortunate enough to play over there a few years ago. So right now I'm spending my time doing a little bit of special projects here with Vector, and more of that time on the golf course. So we can, at this point, let's move forward to see what we're going to talk about today. One of the things we're going to talk about in this series is I'm going to start by talking about some of the different technologies and methodologies that are available for repairing culverts. We're going to take a look at what is a geopolymer, the material itself. Take a look at some of its specific properties that are particularly advantageous to using it as a lining system for a culvert. Then I'm going to show you a few videos on a demonstration that was done for me that gives you a real good idea of the material itself, consistencies, how it works, that sort of thing. I'm going to talk about the design methodology, in particular the design methodology that that we use in determining the thickness of a lining system and how that becomes a structural enhancement. And then I'm going to close it off by taking a look at some case studies, some specific projects, the culverts that we did here at Vector. So what are some of the techniques that are used to repair culverts? Well, the first, the oldest and the easiest is remove and replace, just an open cut system. The next one is placing and new culvert inside the old culvert and grouting around it. Another one we'll take a quick look at is slip lining, which is really a sort of a specialized version of the culvert in the culvert program. And then we'll take a look at some cured in place lining systems, special fiberglass GFRP sectional liner system, and then the spray applied lining system, which we're going to spend most of the time on today. Just to note, with all these different methodologies, all of them have their place, all of them the specific spots where they make the most sense. So it's not just one version fits all. So when you're looking at lining something like a culvert or a pipe, then you can take a look at these different systems and pick which one that you feel is going to work the best. Excuse me. First one, the old-fashioned style where you just remove and replace the culvert. You'll dig it up, take the old culvert out, put a new culvert back in again, backfill everything, and repave the road. This one definitely is the most economical as far as material goes, often even installation goes. The downside is, as you can see here, you're going to lose your road. So you either have to create a detour, create a bypass, shut down the road for a period of time. And in some cases, in a lot of cases, those costs can actually be so substantial and the disruption can be so bad that you want to take a look at a system where you can actually restore the culvert without having to tear all of this up. The first option to take a look at is a culvert in a culvert, and there's a variety of different types of materials we can use for this. We could take an existing corrugated metal pipe culvert, slide it through the old culvert and grout around the outside. You can use just a plastic pipe, which looks like it is here. You can use a specialized HDPE pipe. All of them work similar in that what you're doing is you're putting a pipe inside the culvert, filling the space between the new culvert and the old culvert, and allowing the water to flow through that. One of the disadvantages of this one here is, as you can see in these pictures, you can lose a lot of volume. So if you're concerned about keeping the volume of your flow up through your culvert, this may not be the option to go with. If you can go with a reduced flow, again, it can be relatively simple and easy to do. Slip lining is, say, a version of a culvert in the culvert. In this case, what you have is a plastic culvert tube that you can actually pull through the existing culvert. The upside of this system is that the culvert that you're pulling through can actually be much closer to the size of the existing culvert than if you're just trying to put through a corrugated metal pipe culvert. You're still going to have an annular space around the outside of somewhere between minimum 4 to 8 inches. So you are going to lose some volume, but you won't lose quite as much volume as those other systems we saw earlier. Another version is a cured in place system. These systems here are used a lot in the sewer industry, some in the culvert industry. The big thing about them is that because their material that you're putting in here is generally a vinyl ester or polyester, it is something that has excellent chemical resistance. So ideal for more sewer applications, less needed in a culvert application. The way these often work is that you've got basically a large sock. You take the sock, impregnate it with the resin that you're going to be using, pull it through the pipe, And then what you do is you actually inflate the sock using high pressure air, sometimes high pressure water, and get the sock up tight against the wall, and then allow that to cure. And what they'll end up with is a full polyester or vinyl ester liner on the inside of the culvert. Another one's similar to that, but a little more fancy, is a fiberglass sectional liner. These are sections of fiberglass that are specifically designed in the shop based on very, very tight measurements that you take in the field. So you actually have to go out into the field, make measurements all along the pipe, create the fiberglass liners, and then take them, install them in place, seal the joints, and then grout around the outside. Fairly labor intensive, but it is a very, very effective system, again, where you've got high chemicals because of the chemical resistance of the fiberglass. Then there's a area of spray applied lining systems. That's what we're going to spend most of our time talking about today. These spray applied liner systems, there are systems on the market that are cement-based liners. There are ones that are based on the geopolymer, and it's the geopolymer one that we're going to talk about today. But in this case, what you're doing is you're taking a cementitious type material, spraying it onto the inside of the pipe, allowing that to cure out, and then what you're going to end up with is actually a pipe within a pipe that can be designed to be a standalone structural member. So in looking at that, what are some of the things that reasons why you would go to a spray applied lining system? One of the first ones is that you can do a lot of lining in a relatively short period of time. You can get in there, set up your equipment, and start spraying. And once you start spraying, you can line a lot of culvert in a day. So it's pretty quick to get in, get out, and get done with the lining system. With your choice of materials, particularly with the geopolymer, you're getting a very, very strong, very, very low permeability material that can handle the environment. It looks like a cementitious material, works like a cementitious material, and as you'll see later, it's not a cementitious material. One of the things that can be done with the spray applied lining system, depending on the size of the culvert and the configuration, is you can actually design the thickness of the liner so that it will create a pipe within a pipe. So the material you're installing is actually structurally independent of the culvert or pipe that you're putting inside, and can create a long-term solution that way. If for some reason you want to have it a little bit, you need a little bit more structural capacity to it, then you can use some standard types of reinforcing systems, whether that's welded wire mesh, standard reinforcing steel. In some cases, we've actually even used a carbon fiber grid for reinforcing the liners. But all of this is stuff that is designable if you once you get into it, and can create the system that you want. So, what is a geopolymer? Well, let's start with what it's not. It's not a plastic, so it's not an HDPE, it's not a PVC, it's not epoxy. Even though it's got polymer in the name, it is technically a two-component material, but it's not a two-component material like you would have with the epoxy. Now, it looks like a cementitious material, it feels like a cementitious material, it's got the workability of a cementitious material. Its material properties are very similar to a cementitious material in that some of the ratios between tensile strength and compressive strength are much the same. Has a service life that's as good as, or even better than cementitious material, but it's not a cementitious material. It's actually more of a stone, more of a ceramic. When you mix it up, it becomes a very, very monolithic, durable, and pretty chemical resistant material that you can use for the lining. Very, very interesting material itself, and that's really what caught my attention when I first started it. Some of its material properties are amazing, and we'll take a look at those in a second here. For the chemists in the group, On the left is the molecular structure of a typical cementitious type material. You can see that there's a few linkages, a few different atoms in there. On the right is the chemical structure for the geopolymer. In looking at that, you can see how much cross-linking is in there, how tight the configuration is, and all the different elements that are in there that create the special properties of the geopolymer material. And we'll refer back to that on a number of occasions here. One of the things we need to know when we're looking at materials, and this is not just geopolymers, but epoxies, many other materials, is not all geopolymers are the same. When you're looking at geopolymer, one of the key pieces that we're going to look at is the flexural strength of the material, which is actually the key component in the design of a lining system. But there's two different methods that people use for testing for flexural strength, and I'll get into a little more detail about those in a moment. One of the things you want to take a look at with the geopolymers is the geopolymer you're going to be using, does it have laboratory testing that backs up its material, its properties? Also, are any of those lab testings published in peer-reviewed journals? Peer-reviewed journals are generally set up, and those are what are used as to create industry standards, things like documents, codes for ACI. To be able to refer to that in one of those documents, it has to be published in a peer-reviewed journal. So when you're looking at the material, make sure that you can get your information about the material through there. You want to look for geopolymer that has a specific design methodology, and preferably a design methodology that is based and proven through laboratory testing. There's design methodologies out there that are based on a lot of theory, but look for one that has the design methodology with some backup of laboratory testing. Another interesting feature of the geopolymer is its self-bonding capabilities, and again, I'll talk about this a little bit more in detail later on, but make sure that if someone says that they have self-bonding capabilities, that they actually have the lab testing that's available to back that up. And like with most materials, if you're going to be choosing material, look for one that's got a long history of installations, field installations. Get references, follow up on those references to make sure that what you're getting is what you want. So what's unique about the geopolymer mortars? Well, one of the things that's happened over the years, the geopolymer, if you're familiar with it at all, is actually a two-component material. When they first came out onto the market, you had an alkaline material that you mixed with a pozzolan powder. Mixing those two together created a chemical reaction, and that's what actually causes the geopolymer to harden and get its physical properties. What's happened over the last number of years is the technology has gone so that all of that chemistry is placed into the powder, and this is now just a add water and go type of material. It makes it much easier to use in the field, a lot less specific. Working with the alkaline material in the system used to be rather hazardous and had to be very precise. So this allows it to be able to be done in the field. One thing I need to note here is water is added to the system, one as a catalyst for the reaction, two, something to make the material more pumpable and workable, but it does not become part of the chemical reaction. So we'll see how that affects some of the physical properties. Another thing with the geopolymers is many of them have been tested by the Environmental Protection Agency to be safe for use. Different than what the cured in place systems that are generally fiberglass or polyester. The geopolymer systems are styrene free, so they're very non-toxic. There's actually a version of the geopolymer available that is NSF 61 approved for potable water. So being approved for potable water just shows how environmentally friendly that is. So what are some of the physical properties that make the geopolymer, one, a special material, and two, ideal for lining culverts and piping systems? Look, a few of them here. One of them is taking a look at the tensile strength. The tensile strength of a geopolymer is about double what you would get with a standard cementitious material. So we were talking earlier about that cross linkage and that tight cross linkage. That's what makes this material so tough, so strong, and ideal for these applications. Abrasion resistance, again, because of its toughness, the abrasion resistance of a geopolymer material is about double what you would get for a standard cementitious material. Shrinkage, again, because the water is not part of the chemical reaction, the geopolymer material, actually it shows here 0 shrinkage. I've been in the concrete business for too long to even be able to say the words 0 shrinkage, but the shrinkages are very, very minimal. So if you think that you're going to be lining a culvert that's somewhere between 50 and 200 feet long, if you can put a material in here there that doesn't shrink, then you're going to reduce significantly or eliminate the possible cracking. Freeze-thaw durability, again, because the material is so dense, it doesn't allow moisture to penetrate. So you're going to get, in this case, it shows zero losses using the ASTM C666 test over 300 cycles. So excellent freeze-thaw resistance. But the key feature of the material is the high flexural strength. Because of that tightness, that cross linkage, and the strength of the material, the flexural strength of the geopolymer is up to 3 times more than what you would get with a conventional cementitious repair mortar. And so it makes it ideal for a lining application, particularly a structural lining application where we're relying on that flexural strength for our structural integrity. So I mentioned earlier about the ASTM testing that's done for flexural strength. There are 2 tests that are used in the field. There's the ASTM C293, but the ASTM C293 is actually a measurement for modulus of rupture, which is similar to flexural strength, but a little bit different. The ASTM C78 is the test that's specifically designed to determine the flexural strength of mortar systems. The difference is because this C293 test is for modulus of rupture, it loads the specimen very, very rapidly. And because of that, what happens is that the results you get for the exact same material in the exact same beam is significantly higher. Its reported strength is significantly higher than what you would get for the C78 test, somewhere in this neighborhood of 10 to 15% higher. So when you're looking at the material and looking at the test data for geopolymer, see which test is being reported. What I like to see is the use of the C78 test as the test for reporting flexural strength. 1, because it is actually a flexural strength test, and 2, it becomes more representative of what you're going to actually get out in the field. Another really interesting property of the geopolymer material is that when you install it, it doesn't create any cold joints, similar to what you would get from a regular cementitious material. To prove this out, there was actually some relatively basic testing done, but I think it really shows the material well. A series of cylinders were cast. The bottom half of the cylinders were cast with a 45-degree angle on them, like you can see here in the photo. And then what was done was the top half of that cylinder was repoured, some of it 1 day later, some of it 7 days later, some of them 14 days later, and some of them even 28 days later, with no surface preparation at all on that joint. Those cylinders were left to cure for another 28 days, and then a standard compression test was done on those cylinders. And the geopolymer material, when the compression test was done, all of those cylinders failed as a standard compression cone test. None of them failed along the joint line. If you do this with a regular cementitious mortar, you would find that the failure would be right along that bond line. So being a layered system with the geopolymer, if you go in, spray your system, come back, spray in a second layer of material, then you know that you're actually getting a monolithic bond there and getting a monolithic material. Here are some, this was a demonstration that was set up when I was actually first looking at the geopolymer material to see if it made sense for Vector to take on this technology. And I think this shows you a pretty good idea of the material itself and how it works. This shows you the consistency of the material that's going to be sprayed up on the lining system. You can see here it's relatively loose material, easy to spray. This video is not to show that you do not have to use proper PPE when you're working with the geopolymer. Here's how it's just being hand sprayed. What this was interesting, particularly for me, it's being sprayed onto a plastic tub. And I was amazed at how well it hung up on that plastic tub. And it will hang even better, you know, if you're putting it onto something that's a little bit rougher, like a metal or steel, but it hung very, very well. You can see a little bit of sagging here. On here it was sprayed on somewhere in the neighborhood of a quarter to half an inch, but held up really, really well. Then the other part of the demonstration was being able to spray it in a vertical manner. This is demonstration for manholes. Here you can see the spin cast unit. The way this works is the geopolymer material is pumped down this black hose, air is pumped down the red hose. It causes the head here to spin and shoot the material out against the wall. Here you can see it spraying out. If you look at the right-hand side here, you can actually see the layers going up on the wall. In this case, the spin cast was moved up and down relatively quickly, so the layers that were being sprayed on here were relatively thin. It looks like there's a lot of dust showing here, but I think a lot of that was just a reflection with the camera. But you can see here how the material just goes on in layers, and this is the sort of finish that you will get with that. Then a culvert system was set up. There's a 4-foot diameter culvert, and here you can see how the material gets sprayed in a culvert. You've got your spin casters, similar to what we had. The material is pumped down here, spun out, shoots at high velocity against the wall, so that it actually impacts onto the wall to stay there. And the way it works is that this sled here is pulled back slowly at a specific rate. And we actually have calculations to say, okay, with this certain amount of material being pumped down the line, what speed do we have to pull this sled back so that we get a uniform thickness on the wall? And so that works out really well. Generally, with culverts, we're going to be spraying thicknesses of somewhere between ½ an inch and 1 inch per lift, and that all depends on how much material we want in the long run. Here's a quick look at the culvert that's about half sprayed. You can see on the right here sort of the consistency of what's going on. In this case, that's likely somewhere around ½ an inch of material being sprayed on. Quick before and after look at a pipe. On the left here, you can see the deteriorated pipe and what you'll end up with a final product with the spray applied lining system. Here's a short video on an application on a very corroded culvert. You can see here how badly corroded the steel is. In this case, that's fine. You can see the holes and the leaks. Well, in this case, all those holes and all those leaks need to be stopped ahead of time. All have to be closed up. The water has to be sealed. This is generally done with a hydraulic cement and is part of the system. Then what you do is you set up the equipment, get that going, and in here you can see the actual spin caster spraying the inside of that corroded culvert. You see the material going on the walls here. Here we can see it in a high speed. We've been trying to get our guys to work at 30 times regular speed, but we haven't quite been able to get that going yet. And then here you can see the final product. You've got a nice structural liner inside that corroded culvert, and this is extending the life of this system by upwards to we say 25 to 40 years, and according to some data, it could be even longer than that. So let's take a look at the design methodology for designing a culvert lining so that it is actually structurally independent. This is a design methodology that we use. It goes back to the basics. If you've done any design work, if your resisting moment is greater than the applied moment, then your structure is going to stay in place. The applied moment that we're going to be looking at is actually the moment at the crown of the reinforced system that is created when you apply a surface load to it. The resisting moment is just based on the geometry. What you've got is a cylinder here, and based on the cylinder, you get this moment, the moment resistance, which is the modulus of the material times the flexural strength of the material divided by the distance to the neutral axis. For simplicity and conservative, what we do in our design is we take the neutral axis equal to the thickness. So this gives us a built-in almost 2-to-1 safety factor. It also creates an easier calculation. So what we'll end up for a resisting moment is that the thickness squared times the flexural strength of the material divided by 12 will get us the resisting moment of the liner that we're installing. For the applied moment, what we did was went to the book, The Structural Mechanics of a Buried Pipe, which shows a setup that I think is very representative of what we have with a culvert lining system. It's called an arch beam design. So what we have is we are using an arch of a quarter of the pipe with pin connections on either end and a uniform applied load. For that, we get a resistance, an applied load moment of 0.00262 times P, which is the load, times the radius of your lining squared. So when you combine those and make the resisting moment equal to the applied moment, then you'll end up with this configuration here. You reduce that back to determine what you're trying to calculate, which is the thickness of the liner, and you come up with this design equation. The key pieces of this design equation is that the thickness is proportional to the load that's on there. It's proportional to the size of the culvert. So the larger the load, the larger the size of the culvert, the thicker it needs to be. But it's reduced by the flexural strength of the material. So the higher the flexural strength of the material, the thinner the liner can be to give you that regular structural capacity. Two other factors that are in here. One, the N is a safety factor, which is we are generally working as 2, and C is a factor to look at pipes that are slightly out of round and how that will affect it. Now, one of the things I liked about this design methodology is that it was actually based on testing that was done at the Trenchless Technology Center in Louisiana Tech. In this case, a whole variety of different configurations were set up. Tests were done on reinforced concrete pipe. Some tests were done on corrugated metal pipe. So all of those samples were spin cast using the same method as would be used in the field. Different thicknesses of lining were created on different sizes of pipe, and all of those were tested in the lab in what's called a deload test. See the configuration here. It's actually a very standard test that's done for concrete pipe. It applies a load at the top of the pipe, has a support at the bottom, and as you load it up, eventually it will break the pipe. There was a lot of different configurations, but for today, what we're going to look at is we're interested in corrugated metal pipe. So this is a load deflection curve for a 36-inch diameter pipe with 2 inches of geopolymer liner on it. As you can see, the orange line here, this was a corrugated metal pipe that was tested in a deload test. As you can see, the deload test is not designed for testing corrugated metal pipe. It basically just crushed. Because with the corrugated metal pipe, we're relying so much on the soil load distributions for making that pipe effective. But once that culvert was lined, you can see the significant increase in strength in the load deflection curve with the liner in place. It increases up. You can see here, this is actually the location of first cracking, which is likely in the crown. And so what we want to do in our design methodology is make sure that we stay at a load that is below this first cracking. And in the real situation, if you take a look at it in the field, most of the loadings that we're going to get with in the field are somewhere down in this 1,000-pound range. So in this lower section of this curve, so we have a lot of safety factor in this design. But it is very, very calculable, and that's one of the things I liked about it. Again, this is the formula that we have, so that we know the loading, we know the size of the culvert, we know the flexural strength of the material, so we can calculate a thickness for the material under this specific load for this size of culvert that can be a structurally independent pipe. This just is a spreadsheet that we put together that we can put all our parameters in, and it will come out with a calculated thickness for us, and that's what we're able to use for our design. So that's a lot of the theory behind it, but have you actually done this stuff out in the field? So here's a few case studies on projects that we did at Vector. This is one that was done in North Vancouver, British Columbia. A 4-foot diameter culvert. You can see the before and after view here. Interesting piece about this job, it was actually done on a residential street with expensive houses on either side, expensive properties on either side, with access to the pipe relatively limited. The top right-hand corner is the intake of the pipe. The bottom left is the outflow of the pipe. So you can see what it's doing. In this case, we had to do some repair work on the invert of the pipe ahead of time. We're able to actually install a gravity feed bypass system for this project. You can see here where the intake is, we dammed it off, the water flows through, and we're able to actually do the repairs without having to pump material. The day we did spray the liner, we actually did set up a pumping system and pumped over top of the road, so we didn't have the pipes going through here. That made the work easier, but it's not mandatory at all. Here's a look at the inside of the pipe. Once we got all the junk out of it, you can see here some of the holes in the invert, some of the invert that was missing. So what had to be done here is all that had to be patched up. So the geopolymer material was mixed up in a mortar form and a slurry form, and the whole bottom of the invert was patched ahead of time to seal all that off, to dry it up, and to get a good surface to spray to. Again, here's a look at the setup with the diversion through it, and you can see in the bottom here how the bottom of that culvert has been lined. Here's the setup. Guys are getting ready to spray. You can see the spin caster set up on the sled. Again, the calculations have been done, knowing the amount of material that was going to be coming to the spin caster, knowing the size of the pipe. We have a variable speed winch that pulls back the sled in at a consistent speed to get you a uniform layer on the outside of the culvert. Here's a look at the inside after it had been sprayed. So you can see a very, very effective lining system that's going to extend the life of the culvert. This is a project that was done out in California. 2 culverts in a much more remote area, much the same size as the other culverts in North Vancouver. In this case, the bypass was easier in that the water was diverted through one culvert while working on the second culvert. So very, very good there. This culvert again had some issues. You can see the holes in the invert of the culvert. All of that was patched up ahead of time. And then the setup was in place to spray it. In this slide, you can see the winch system. Cable goes in. You're pulling the sled through the culvert and spraying the lining system. And here you see the final result. Again, a very nice monolithic, durable lining. This is a project done in Vernon, British Columbia. A very different setup. That this was a large arch culvert. You can see here the setup. For this one, the dewatering system was even more elaborate. What was done was that the creek was dammed off. Huge, large pumps were used, but we had to pump right through the culvert where we're working. So we had to work around these pipes, which was very doable and worked out well here. once we got in here, we found that there was a lot of leakage from groundwater going into the pipe. So actually a chemical grouting was done ahead of time. Went in, drilled holes through the culvert, pumped a urethane chemical grout in behind to stop the water. And you can see how dry we were able to get the pipe before we sprayed it. You can see the diversion pipe here hung up in place, so out of the way. In this case, we chose to spray it by hand using a hand wand. Because of the size and the configuration of the pipe, this just made more application sense. And here you can see the finished product with a structural liner on the inside of the pipe. Last job I'm going to show you is a large diameter pipes underneath the Trans-Canada Highway near Ignis, Manitoba, Ontario, not too far from Thunder Bay. These were 10-foot. These were 10-foot diameter culverts, so very, very large. The inverts here were rusted, but they weren't badly pitted, so we didn't have to do any special work there. In this case, the river was diverted by cofferdaming. So cofferdammed off one culvert, allowed the water to flow through the second culvert, and we're able to work in a dry environment that way. Again, because of the size of this culvert and the configuration, it was decided to spray those by hand spraying them. So you can see here, and then putting on the initial pass of the liner, going back and finishing it off, and again getting a fully lined structural pipe inside the pipe of the culvert. In this case, something that's up to 10-foot diameter. I believe the design thickness here ended up being somewhere around 3 inches or 75 millimeters to give us a structural pipe within a pipe. So that's an overview of the geopolymer material itself, some of the properties of it, how we come up with the design for design thickness, and some idea of some of the different types of projects that we've done at Vector. So with that, I will turn it back over to Scott and see if anybody has any questions.
Fantastic, Garth. Sorry, I always get a little bit of echo when I come back on here. Bear with me. So we have a fair amount of questions here. We'll see how many we can get through here. Just so you know, Garth, you'll be selecting the best question of all the bunch to receive an Amazon gift card. And we may not get to all of them today, but you can select them afterwards, and I'll make sure the lucky recipient gets their gift card.
If I'd known that, I would have asked the question.
Well, let's go through maybe in chronological order here. So from Anonymous, who I don't have the name for yet, for the spray-on liner, is it designed to carry the full loads carried by the existing culvert?
Yeah, the design is for the full loads designed of the existing culvert. Only exception is that actually very deep culverts testing and has shown that there's a significant arching action of the soil. So for culverts that are deeper than 3 culvert diameters, we actually only need to use the 3 culvert diameters height of soil on top of it because of the arching action. But yes, other than that, it's full dead load and design and live load of the applied load for the structure.
Okay, here's a good one. What is the fire rating for the geopolymer mortar? The
geopolymer mortar is very similar to a cementitious mortar. It doesn't burn, it doesn't deteriorate. If you get temperatures that are exceedingly high, the same with the regular concrete, there would be concerns, but there's really actually no fire rating issues with the liner, similar to what you would get with standard concrete.
Okay, good stuff. If anyone wants to ask more questions here and be considered for the gift card, please submit them now. I see a few more coming in. Okay, next question from our good friend Ken Lockett. For the geospray, he has actually a few questions here. For the geospray, what is the minimum size of culvert that this can be applied in? What's the typical thickness of the liner, I guess, as it relates to the diameter? And has this been used in a railway application and has it been tested? There's a lot of questions here. Has it been tested to E80 loading? So the first question is size of culvert and thickness. That has it been used in railway applications, and then been tested for E80?
Okay, size of culvert. and I'm sorry, I'm going to still be working in inches here. Size of culvert, ideally you want to be larger than 4 feet or larger. We've done projects down as small as 30 inches, but generally 4 feet or larger. Design thickness, the typical design thickness for a 4-foot diameter culvert, running a liner thickness of about 1 inch. If you're getting up to, like I said, that 10-foot culvert we did, the thicknesses are somewhere in the neighborhood of 3 to 4 inches. It has been used in railway applications and it is designable for railway load. In the testing, but it's been tested up to failure, which is basically first cracking and beyond. The loadings you would find with the I can't remember the number, sorry, of a railway load are significantly lower than what those failure loads were for the test. And actually, in that spreadsheet that I showed you, we actually have a drop down for applying the railway loads into that situation.
Okay, just following up on another question from Ken here. Can the geospray be applied to brick arch culverts or masonry stone culverts?
Yeah, actually, that's a really good question. Yeah, it can be applied to both brick, stone, and concrete culverts. There's actually several applications where it's been applied in brick, more sewer lines for brick than in roadways and railways. But there's a design, because it's independent of the material you're placing it on, can be done there. And there's actually some real good applications showing what can be done in a brick environment. And if he's looking for some of those, we can get him some case studies done on brick.
Awesome. I'm glad you left time for questions here, man. There's more coming in all the time. Again, anonymous, we'll find out who this person is, but another good question on size. Is there a limit on how big the pipe can be?
There's no limit on how big the pipe can be. The application method, you may end up having to get scaffolding or something into pipe to be able to spray it. I know structures have been done that are up to 20+ feet in diameter. Once you get into those sizes, if you're looking for an actual structural application, you're going to get into some fairly thick material. Generally, too, that's a situation on a large pipe like that where you may actually look at adding some type of steel reinforcement into the liner to give it a little bit more structural capacity. Okay.
Man, our buddy Ken is certainly stacking the deck here in his favor for this gift card. He's got another question here. Typically, when you are repairing a culvert, the bottom is holed or perforated and in not perfect condition. Can the sled be adapted to spray the bottom of the pipe is holed from the end to end? I guess he's asking. Yeah, I'm trying to interpret that question.
Yeah. The way I'm understanding that, the sled itself is designed to spray centrifugally, so it's a whole pipe at one time. If we wanted to go in and on a larger culvert needing to do a larger area to repair the invert, what we'd end up using is the hand spray method that we used on those larger pipes. It's a good way to get a lot of material into place in a relatively short period of time. And then what you'd end up with is in that case, having somebody coming back after you spray it, working it with a trowel, so you can actually push the material down into those holes to make sure that you're getting them sealed.
Okay, back to anonymous. This person's popular too. Does the geopolymer mortar or geopolymer change the pipe characteristics, friction, roughness, coefficients, etc.?
Another good question. Corrugated metal pipe, when you're looking at flow characteristics and roughness, has a Manning number of somewhere around 0.0028. The larger the Manning number, the rougher the flow. When you go in and spray it, you're actually smoothing out the pipe a little bit, and actually your flow rate, Manning flow rate of a geopolymer lined corrugated metal pipe culvert is actually, the flow characteristics are slightly better than the original culvert. So in rough situation, even though you're reducing the size of the culvert, your overall flow rate for the culvert will stay relatively the same. And because you're reducing it so small, you're really not increasing your velocities. They're going to cause you any real grief with the fish in the culvert. Roughness, it's a little bit rougher, but it is a very durable surface.
Okay. Anonymous has another question here. Has this this is the one I think is going to stump you, Garth. Has this technology been proven and used to line pressure vessels?
It has been used to line some pressure vessels, pressured reinforced concrete pipe. I don't know of any specific testing that has been done on particularly internal pressures pushing out on a culvert, but you're basically creating a concrete pipe inside a concrete pipe, so it's very, very similar. But I don't know of any specific testing that's been done on that. Okay,
good stuff. You weren't stumped by that one at all. What's the next one here? Sorry. Missing one here. Oh, Cameron Ewan. Does the geopolymer change the pipe characteristics for? Oh, he's already that was him from before. Sorry. Okay, we're on to Ken Wachowski, and actually, just want to note here, Ken is one of the only people who has attended all of our webinars this year so far. He's on today, and he's been on the past 11 from our records. So thank you, Ken, for joining us for all 12. And there's another gentleman, Travis Hopper from Pennsylvania, who also was on all 12. So we'll send you a t-shirt. It's in the mail. Ken is asking, how many state DOTs have approved the use of geopolymer mortars as a rehabilitation alternative?
I don't have a specific number. Actually, in my regular presentation, I actually have a slide showing the approval rate. From what I recall there, the states that actually have it approved is well over half of them, with most of the others at the time that I had this, I saw the slide, had pending approvals. So at this point, I would think that pretty much all of these state DOTs have approved the geopolymer material as a lining system for culverts.
Gotcha. Okay. Question, does the coating arrest corrosion in a rusted corrugated metal pipe? Yeah, it does, because it creates a barrier, particularly a barrier with some thickness and some impermeability to keep the moisture from the inside getting to the pipe. It does not do anything with the moisture coming from the outside of the pipe. Unlike a cementitious material, the contact spot is not as alkali, so it doesn't provide that passive layer that we would get on reinforcing steel. But again, we're creating a pipe within a pipe, so we're not relying on the existing structure as part of the structural integrity of the system. So I guess the bottom line is it would definitely slow down the corrosion of the existing pipe, but I wouldn't necessarily stop it. Gotcha. And then next question is very similar from Brayerman. Sorry about that. Many owners want full structural replacement for deteriorated culverts. Does geopolymer material provide corrosion protection to steel similar to other cementitious materials? This might convince owners to consider remaining strength of steel culverts after application. Yeah, the response to that's pretty much the same as before. What we're doing is we're creating a virtually impermeable liner with some thickness on the inside of the culvert, so that the interior of the culvert, like the deterioration that we see on the inverts, is from the water that's flowing through the culvert. That area is protected by the geopolymer liner on the inside. So it does extend the life of the existing corrugated metal culvert by putting the liner on the inside of it. Okay. Justin Clark has a question. Man, we're getting through a lot of today. We only have a couple more minutes, but we'll get through as many as we can. What QA/QC methods can be used to verify the applied material thickness and strength? Okay, well, thickness and strength, one of the things for strength is that we actually will take some test cylinders, and we collect the material for those test cylinders right at the sled. So we'll take those, be able to test the compression strength of the material at that point.
As far as QA/QC, what we're looking at primarily for this is consistency of the material so that it's sprayable and will hang properly. And then if we get to compressive strength, very, very similar to concrete, if you have a good compressive strength of the material, generally all of your other material properties fall into line with that, things like flexural strength, tensile strength, permeability, those sorts of things. So as far as QA/QC, the biggest thing that we do is collect samples and do compression testing.
Okay, and this is a similar to another question we have here from Roger Stanley. Can you discuss if the geopolymer liner is pre-approved in various DOTs like PennDOT or New Jersey DOT? Do you happen to know that off the top of your head?
I don't know those ones specifically, but we can definitely get back to you on what specific states are approved. I don't know about those ones in particular off the top of my head.
It was a large number in the U.S., if I recall. So
it's about 80% of them at this point, where the geopolymer geospray is approved as a lining system for culvert repairs.
Perfect. Our good friend Ashok has a question here. Can the geopolymer spray liner be used on a concrete bridge fender system?
I'm not that familiar with what the fender system is, but the geopolymer material can be used for lining any concrete. It bonds really, really well to existing concrete. Likely not in a structural application. If we look at something like a box culvert or something like that, we can create a lining system inside those to provide protection. The geopolymer has also been used as a repair material. So if you're actually having to do some concrete repairs, either with or without a lining system, you can actually spray apply the geopolymer into the chipped out area and repair it, or provide a liner on any concrete surface, and it works really, really well for that. Again, once we're done, I'll find out a little bit more about what a fender system is and create a response specifically to that.
Thanks, Garth. We're coming to the close here, so I'm just going to pick the last two questions. We're not going to get to them all today. One would be from Ashok again. It's a good question. Can you use this liner or the liner system on a deck overlay or for waterproofing?
Oh, great system. Yeah, it actually can be used as a spray applied system for restoring a deck on whether it's a bridge or parking structure. Its durability, like I mentioned earlier, the abrasion resistance is about 2 times what you get with a standard cementitious material. So excellent abrasion resistance that way. The thickness of it will provide significant waterproofing to a deck. There is actually a self-leveling version of the material as well that can be applied to deck if that makes more sense than spraying it. But it's an ideal application, alternate to culverts for it.
Okay, last question, and I'm just picking it at random from Anonymous. What's the difference between a geopolymer and a standard shotcrete?
The big difference between the geopolymer and the shotcrete is the material itself. The geopolymer is that specialized engineered material that we talked about with those enhanced structural properties, particularly that enhanced flexural strength, the enhanced abrasion resistance, the zero shrinkage, the freeze-thaw durability. Whereas a standard shotcrete is a cementitious material, uses the water in the reaction. So the key business differences for me is the enhanced flexural strength capacity and the low shrinkage.
So Julie from Nebraska is asking, what would you recommend as the best application to maintain headwater elevation and outlet velocities or impact the least? And what would you recommend for broken or double broken back culverts?
If you're looking at trying to maintain headwater and tailwater flows, you want to go with something that's relatively thin. The nice thing about the spray applied lining systems is that when they're sprayed, they reduce the size of the culvert, not too much, a little bit, but not too much. But also, if you take a look at the Manning's numbers and get into it, you're actually improving the Manning's flow because you're getting rid of the bumps on the culvert by a little bit. And as it works out, the improvement in manic characteristics and flow characteristics pretty much balance out the reduction size of the culvert. So you get the same flow through the culvert, so you'll have pretty much the same head, same tail for the culvert. The other nice thing is because these numbers are so small, it really doesn't influence the velocity, so it doesn't hurt the fish. As far as if you get into broken back systems, you're likely looking at wanting to do something that's a little bit more of a predetermined lining system, culvert and culvert situation. If you can handle the reduced flow. If you can't handle the reduced flow, what you may have to do is go in there and actually do some physical repairs, physical strengthening at those locations, and then come up with a geospray system or geopolymer system or something else.
Very good. Follow-up question from Julie, and I know Julie's putting in extra ballots to get the best question so she can get a gift card here, Garth, but she's looking at the cost. So how do these costs compare with, say, an open cut solution or jack and bore or a complete replacement?
With the remove and replace, the biggest difference in cost there is what's your diversion going to cost you? What is your bypass going to cost you? As far as just removing and replacing it, that portion of it, all of the lining systems are significantly more expensive than just digging up a pipe and putting it in. But when you take into account having to put diversions in, traffic control, that sort of thing, that's extremely variable and will bring your costs up to the same level, and in many cases even more expensive than you would with the other lining systems.
Okay.
What was the rest of the question there? Sorry.
Just difference in cost.
Yeah. What you'll find is the spray applied lining system, once you get into pipes that are larger than 4 feet, they become a more economical system. In the smaller pipes, that's where some of the slip lining, the cured in place systems can be economically competitive to a sprayed lining system. Once you get up into that 5, 6, 8 feet size culvert systems, the spray applied lining systems are significantly less expensive.
Awesome. We have a lot of questions still coming in, Garth, so I'm just doing in chronological order. I'll pick a few, but we won't be able to get to all of them today. So are you committed to answering some questions via email?
Yes, I can do that.
Okay. What's the difference between a cut-in culvert and slip lining? Anonymous would like to know.
A cut-in culvert and slip lining. You know what? Got me on that one. I know what the slip lining and a cutting culvert is a new term that I haven't heard before.
Well, I think Anonymous just won a gift card, but unfortunately we don't know who Anonymous is. So Rick wants to know what's the diameter of culverts. So what diameter of culverts is more economical to use with centrifugal spray versus gunite or shotcrete?
Well, gunite and shotcrete is a very different technology. With gunite and shotcrete, you're generally looking at a minimum of 4-inch diameter, a 4-inch thickness to be able to put in your reinforcing steel and have a sprayed in lining system. You're spraying in a cementitious material, so you'll also have to have that additional thickness for the strength. Once you start spraying in a shotcrete system, you have to actually physically get in there and do it. So you're likely looking at somewhere of 8 foot larger culvert for a spray applied lining shotcrete system to really be practical to install. But you're installing something that's thicker than a geopolymer type system. So cost wise, it likely ends up being pretty much a soft when you're getting into that larger diameters. In the smaller diameter systems, there's just not the practicality of spraying up a 4-inch or thicker shotcrete system.
Awesome. We have a question here from Nick. Could the spray on geopolymer be applied to a culvert prior to installation with the same effectiveness versus in-service culverts? If so, are there any advantages to applying the coating to the structure before the deterioration has occurred, like basically using it as in new construction?
Yeah, one of the things that you could do for new construction to install it as a protective system. One is that the protective system could actually go on significantly thicker because you're not looking for a structural component of it. To put it on before you're installed is likely not a good idea because of the loads that the culvert is going to be subjected to while it's being lifted, put into place, backfilled, compacted, those sorts of things, would likely cause the lining system to, best way to put it, be distressed. So what you do is you would install it, then you could go in and spin cast the lining system through the culvert. But again, on a situation, just an example, say you've got an 8-foot diameter culvert that would be designed for a 2-inch thick lining system, you could likely comfortably put an inch on a new culvert to provide the protection and extend the life of the culvert.
Thank you. Medbra Tom, hopefully I got that name right, has a question. Does the geopolymer need a special or separate bonding compound when applied to a corrugated metal pipe? How thick does the liner need to be in order to resist HL93 loading and say 5 feet of overburden? Can geopolymer be applied underwater?
Geopolymer cannot be applied underwater. It's because it's a cementitious type of material. The loading, when you've got a loading system, that loading with 5 feet of soil, we need the size of the culvert to come up with a specific design. But to give you an example, the general rule of thumb is that a 4-foot diameter culvert, the liner needs to be about 1 inch thick. 8-foot diameter culvert design is somewhere in the neighborhood of 2 inches thick. 10-foot diameter, roughly, you're talking 3 inches thick for the application.
Okay. I'm can't pronounce this name. Soki. I'm wondering if the material racks only a small amount of water. How do you spread this evenly over rotted out culvert floor that may be leaking groundwater?
What we would do with that situation, like we showed in those examples, is you go in and actually have to patch the holes, fill the holes with either hydraulic cement or the geopolymer in mortar form before you can actually go in and spray it. You have to physically stop the water, get it very, very reduced before you can actually spin cast spray in the culvert. I got a good bump back. I just remembered a piece of the last question I didn't answer. The question was, do you need any special bonding material to bond to the metal culvert? No, you don't. You're not relying on that bond for anything really other than hanging. It's not a structural component. But what we found is that the geopolymer material sticks really, really well to metal. Where we've learned that is trying to get it off of our tools and equipment after a job is over.
So here's a relevant question from Tom. What are the surface prep requirements when applying to a corroded culvert?
The corroded culvert, what you would do, again, because the bond is not critical, is to go in there with a high pressure water blast to try and get any of the loose material, loose scaling off, and then patch any holes you have there, and then it's ready to go. Another nice thing is both cementitious materials and these geopolymer materials actually bond nicely to rusted surfaces that are rusted but not mill scaled.
Okay, we're getting really close to time, so last question here. I'm just going to pick kind of at random. Ali Reza, if the diversion of water flow is not possible, can the geopolymer mortar still be sprayed in the presence of water in the culvert?
No, you have to, for the geopolymer spray mortar system, the culvert has to be dry. If you're in a situation like that, that's one thing I didn't talk about earlier, but some of the culvert and culvert methods can actually be installed in flowing water. It's not easy, and there's some precautions you need to do, but they can be done like that.
Okay, thank you, Garth. That's all we have for questions and for time. Just gonna say if you have any extra questions or you want to submit something for Garth's consideration for the gift card, you can always email him directly here. You seeing my screen here, Garth? Or yeah, awesome. Just checking. So I'll leave this on the screen for a second. It's garth@vector-construction.com. He still has an email address with Vector Construction despite being retired. So feel free to reach out to him. I know he'd love to hear from you. As I mentioned, this brings us to the conclusion of the bridge preservation series. We're working on another series coming up in September, so check back on the website for more information. Just to repeat though, Garth's presentation today, the slides, as well as the recording from today will be will be available on the Concrete Preservation Alliance website, which is wesafestructures.info under the events tab. And you'll see, just like you have on screen here, there'll be a link to the slides and the recording of the webinar, just like we had for Travis Marmon last month. So this brings us to
the more people that view it, I'm still negotiating my royalties on that.
Yeah, well said, well said. So this brings us to the conclusion of the whole series. So we're wrapping up right now. We thank you for joining us for 1 or 12 of our webinars in the past year. And we hope you learned something and hope you found value in the content presented. I want to thank Garth for wrapping up our series here with a great presentation on culvert rehabilitation using geopolymer mortars. Thank you, Garth.
You're very welcome. And
I want to say one last thank you before we close to an unsung hero of the Concrete Preservation Alliance, Renee Therian, who is silent. She's on the call right now, but she can't speak. She's been instrumental in putting these on throughout the past year and going to the future. So thank you, Renee, for all the early mornings and all the late nights. We really appreciate it. And that wraps everything up. So thanks so much. And again, go out there and save some structures, be safe, and we look forward to seeing you again at a future event, whether it's a parking structure webinar or a marine webinar or anything in the future. Have a great day.